one. However, because it's the aqueous solution, number of moles for second one, it would be calculated differently, and number of mole is going to be molarity times volume in liter. So you find number of moles. We already know how to find the Q, and to find the number of moles, you use the molarity times number of liter or volume in liter. That gives you number of moles. So Q divide by number of moles for second one. That would be delta HN. Q, which is calculated from the mass and change in temperature for the third reaction. Number of mole, because we have sodium hydroxide solid, is going to be calculated from mass divided by molar mass. For the molar mass, you are using periodic table. Sodium is 23, oxygen 16, and hydrogen 1. So you find the molar mass for sodium hydroxide. The concept of this experiment is very, very simple because you're only using basically two simple formulas. So you have the Q, which you need the mass for each step, the specific heat assumed to be like water, and then change in temperature. For the mass also, because for the liquid part, you are using density of water. So for the first part, I did put in separate again, just to make sure that you can follow this for your calculation when you perform the experiment. For part one, you calculate the Q, and delta T and SH is clear. For the mass, you would get the mass of water, density times volume. For the water, because the volume is in milliliter and this is a gram per milliliter, milliliter would cancel. For the mass of the mixture, so you are using mass of the mixture here. The mass of the mixture is the mass of sodium hydroxide solid you're adding plus the mass of water, and you find the mass of water. To find the delta HS, when you find the Q, you also find number of moles using mass divided by molar mass to find the number of moles. 2. Same formula, but different values, because the mass here is the mass of sodium hydroxide solution and HCl solution. You are adding the two together, which is going to be total volume of the two times the density of 1 gram per milliliter. So you have the mass. Specific heat is assumed to be like water, change in temperature experimentally found. So you find the Q. When you find the Q, to find delta HN, you need the moles of sodium hydroxide. Because it's the aqueous solution, it's going to be molarity times volume in liter. For reaction 3, you do the similar calculation. Mass of the mixture is the sodium hydroxide because it's solid, plus the mass of HCl, and to find the mass of HCl, you assume density of 1 and the volume of HCl. Moles of NaOH you find from the mass over molar mass. And that is going to give you the delta HS, delta HN, and delta HSN. The specific heat of the metal is the last part, or part B of this experiment. What are we using to find the specific heat of the metal? We're saying if we have a hot object and cold, hot would lose heat and the cold would gain heat. And you place them in one container, one media, both of them would reach equilibrium. The energy or heat is going to be transferred from hot to the cold until they get the same temperature. So when they get to the same temperature, the amount of the heat lost by hot metal is going to be equal to the heat gained by cold water. And for each one, you can calculate the heat. For Q of the metal is going to be mass of metal, which experimentally found. A specific heat of metal, this is the unknown. Change in temperature is going to be final temperature of metal minus initial temperature of metal. Initial temperature for metal is the temperature of the hot water. So these are explained in the experiment, how to get it. But when you get it, you're doing the calculation. Mass of the water, specific heat of water is 1 calorie per gram degree Celsius or 4.18 joule per gram degree Celsius. Change in temperature. Water from room temperature would increase the temperature because it's gaining heat. It would be like not very significant, but maybe 2, 3, 4 degrees Celsius, sometimes 8 degrees Celsius. Depends on the specific heat of the metal that you have, how much heat is going to be lost from the metal and how much heat is going to be gained from by the water. So initial temperature for the metal is going to be greater than final temperature of the metal. Okay, so the delta T for metal is going to be negative, and that's why we have this negative sign here used in the formula. Okay. Water is going to gain heat, so the final temperature is greater than initial temperature. Delta T for water is going to be positive. Final temperature for metal and water are equal. So from this equation, the SHM is the specific heat of metal, which is unknown. Delta Tm, you find it from the 100 minus Tf, if the 100 is the initial temperature of boiling water. That's basically what 100 means here. Mass of the water, you're using volume times density. Specific heat of water is given. Change in temperature of water is calculated, and now you can find a specific heat for metal if you have everything else. And that is another purpose for this experiment, to find a specific heat of a metal.